or if I ever tried to connect to this IP address again, and the 256 SHA hash here doesn't match when I connect to this again, it's going to deny the connection. So notice that I've able to successfully SSH'd into the system. Okay, who am I? Who am I is a command that I run to see who I am. Let's look. Okay, here is my home directory that I had created the other day. And when we SSH in, it's going to go into that folder. So SSH is a pretty commonly attacked port. And if you have port 22, which is the standard port for SSH open to the internet, you're going to get a lot of attacks. The way we need to solve this practically is by editing the port so that it doesn't answer on port 22. We need to change that to something that attackers are not going to try. Typically, attackers scan for well-known ports and move on if they don't find anything. So let's bring up an application called Nmap. And just for GUI purposes, I'm going to call up ZenMap, which is the GUI interface to Nmap. So I'm going to scan 192.168.18.131. Right now, I'm going to do a quick scan. A quick scan, denoted with -F, looks at very few ports. It looks at the commonly known ports. So if we scan really quick, we'll notice that it comes back with port 22 TCP is open and it's running SSH. It also gives me the MAC address, and obviously we know the IP address because that's what we typed in. So we need to change the SSH port. So we'll go back to CentOS, and we're actually needing to log out, so let's exit and close the connection. And here on my CentOS system, I'm actually going to change the port that SSH is running on. In order to do that, I'm going to type in vi etc ssh sshd_config. I'm going to scroll down to where it says port 22 and uncomment that line. I'm now going to change that port to 2237. I'm going to escape, write, and quit. Because this is CentOS 7 and SE Linux is turned on, I need to make sure that SE Linux knows that I'm making a port change. In order to do this, I'm going to type in semanage port-a-t ssh_port_t-p TCP, then the 2237. Okay, so what this does is instead of listening on port 22, it's now going to listen on port 2237. And I have to allow that with SE Linux. It's going to think about it a minute. And now I'm going to look at semanage and make sure that it actually took. So I'm going to type in semanage port-l, so listing the port, and I'm going to grep for SSH as the service. Okay, it looks like SSH port-t is listening on now both port 2237 and 22. This is okay as long as we change, which we did, the port that SSH was listening on. The only thing that we need to do now is restart the SSH service. In order to do this, I'm going to type in systemctl space restart space sshd dot service. And let's make sure that SSH is still running. ps aux grep SSH. Okay, it's running again. So let's
Got the man with the plan right here.
try connecting back with Kali Linux. Okay, looks like now I can't SSH into it, but let's type in SSH-P2237 Greg at 192.168.18.131. Let's try to scan our port again and see if it comes back with anything. Okay, and port 22 is now closed. The next thing that I have to do is open the port in the firewall. We'll talk about firewalls in Linux in a couple lessons, but first let's open up the port. The new firewall within CentOS 7 and Red Hat versions is called Firewall D. So I'm going to type in firewall-cmd --zone equals public --add -port equals 2237/TCP. Now I'm going to go back and double check that I can't just see port 2237 open. This shows us that port 22 is open on the firewall, however, there's nothing listening on the port, which is okay in this case until we actually delete the rule out of the firewall. So I'm going to change this to an intent scan and see what it comes back with. This may take a minute. Notice that not even our intent scan, denoted with an A, actually finds anything. So port 2237, while it's a low numbered port, it's not low enough where attackers are going to continually scan it. So it's mainly hidden from attackers. This is called obfuscation, where we're hiding things out in plain sight. If you have SSH turned on port 22 on a public IP address, you probably notice that you're getting attacked quite a bit. If you change the port on SSH, you'll now see that you're able to hide your port and it's not going to get attacked. Let's just make sure that we can actually SSH in now to that port. So I'm going to type in SSH-P for port, and the port number is 2237 Greg at 192.168.18.131. And notice that I can get in now. Understanding that you can hide SSH in plain sight is critical to make sure that your attack surface is lowered. Changing port numbers will help you not allow attackers to keep on trying the same service over and over and over again on port 22. In addition to changing the port, there is another risk of SSH. SSH allows us to enter a password for a user. However, if SSH were ever compromised and an attacker were to change the binary of SSH, they would be able to turn SSH into what we call a honeypot and steal users' credentials. So it's important to also look at other technologies such as two-factor authentication for SSH. This can be done with public and private keys. This also allows us to streamline SSH between systems. So in conclusion, SSH allows us to access other systems, but there are some security vulnerabilities that we need to be aware of when we're implementing the service for users. Changing the port and looking at authentication will go a long way in securing SSH. In this lesson, I will talk about cron, what cron is, and how to use it, and some use cases that I've used in the past. Cron is the command for periodic processing within Linux. Periodic processing is necessary to make sure systems are functioning correctly. Think about how we execute backups at certain times on certain systems. For a Windows backup, it's real easy. It's done by a scheduler. For Mac, it's the same thing. It's done by a scheduler. So why would Linux be any different? Cron is our scheduler. Cron allows us to execute anything we want to arbitrarily at certain times of the day, certain times of the week, and essentially any time that you want it to execute, we can make it run whatever you want it to run. It's more powerful than a lot of the other periodic processing tools on other systems. The benefit to using cron is it's also very easy to manipulate. In order to access cron tab, we just need to type in cron tab -e. This opens up our cron tab for E for everyone. So I'm going to create a new cron tab. Cron tabs come in the form of a configuration file that start out with how we want to process that, or what time of the day, what time of the week, really what time that we want to process the command at the end. The first star indicates a minute, so minutes 0 through 59. If we want it to run every minute, I could say divided by 60. The next is going to be hour. The next is day of the month. Next is month. And finally day of the week. So I should have 5 configuration items for the time period that I need to process this command. Next is the command that I want to run. If I want to run a certain command, I'm going to type in root scripts cron_test.sh. This is a shell script that I created to test cron. If I right click, I see that my cron tab is successful, installing new cron tab. I can look to see what is running by typing in cron tab-l. Now think of cron tab as a scheduler for almost anything, just like I said before. It allows us to back up information, allows us to check on systems. Some of the use cases that I've used cron tab before is testing network to make sure that systems are up and running, to make sure wireless access points are up and running. And if they're not running, execute another script to restart those wireless access points at a certain time. by default, cron sends an email to the user account that is executing the scripts. So in this case, because I'm root and I edited my cron tab, I'm going to receive a lot of emails to the root email account, which luckily isn't set up. However, if I didn't want to receive emails, I also need to type in an additional command after my script. So let's go back into cron tab, and I'm going to take the standard output and actually push that into what we call dev null. We're going to take the standard out and call dev null. And now we've successfully installed our cron tab again. Let's look real quick at where we can go to look to see if cron is actually executing or not. There's a log file located in var log cron. And we can see that we are executing, or that we have loaded our cron tab. So in conclusion, cron tab allows us to do periodic processing on Linux systems. It is a very important part of a system administrator's duties to make sure that our systems are run well, and to make sure the backups are being completed, and also to do periodic processing on anything we need to run automatically in the time that we choose to run that script. And I'll discuss adding. In this lesson, I'll discuss adding users to Linux. Adding users to Linux is a common task that system administrators may perform over the course of managing a Linux system. Now, depending on what scripts that you might have implemented on, let's say, a Kickstart file, for example, the integration that we have with maybe another directory like Active Directory may do some of these tasks for you. But let's go over them individually. So I'll discuss the commands that we use to enter in users into Linux, and some of the caveats that we have as well, and what I've seen over the years. Now, most Linux systems use a command called user add. Now, if I type in sudo user add, and then the account that I want to create, it's going to create not only the home directory, but it's going to create the permissions for that home directory, and also the shell that the user is going to have as well. So I'm just going to enter this here and enter my password for Greg, and now the account is created. I can check that the account is created by doing one of two things. Since I'm already in the home directory, I can just list what files I have. So here's my account, G. Williams, and G. Williams is the user and the group owners of that directory. Additionally, I can go into the etc password file and look to see if the account was created there. But before I do that, let's add a password for my G. Williams account. So I'm going to type in sudo passwd G. Williams, hit enter, and enter password, retype the password, and it's created the password successfully. So let's look at the etc password file for a minute. Here, we'll notice that we have three different users. I have Greg, Greg Test, and G. Williams. The X indicates that I've set a password for that user. I have a user ID, as well as my home directory, and the shell that that user has. Since some of the scripts, because different distributions use UserAdd in different ways, let's look at a more mainstream Linux distribution, such as CentOS, which is the binary equivalent of Red Hat. Typically, we're going to see this distribution being used more in an enterprise environment. So let's get more familiar with what we can change for the defaults. So I'll type in sudo vi etc default user add. So here I can change the group, I can change the home directory, inactive, I can make it active, when the account expires, and the shell, and the create mail spooler. I can change or I can add several other attributes if I would like, but these are the most common that I'm going to use. Now let's go back into the etc password field. On many of these, we notice that there is a shell called sbin no login. This means that we're going to use an account, which is basically a service account, that allows us just to use a service and execute commands, but it doesn't allow the user that we create to log in anywhere. If we want to lock a user out, this is the quickest way to lock somebody out of their account. This would be in the cases if we wanted to, if somebody was leaving the organization. So in conclusion, adding users is a very easy process. We need to understand how we create users and what fields that we need to enter to make sure that we're setting permissions correctly and that the user has a good experience when they log in. In this lesson, I'll discuss securing users. Securing users within Linux is pretty simple. Some of the commands that we've used already, like user add, create files and permissions for users when we add them to Linux. However, if we need to modify something, there are other commands that we need to use. In this lesson, I'll talk about some of those commands and why we want to use certain commands over others. Let's look first at what we've already created. So we'll type in sudo cat etc password. We now have our 4 accounts that we've created. Here's our accounts right here. Now let's say that we want to modify a home directory. So for the user Greg, instead of home Greg for my directory, let's use Greg temp 1. And just to make sure it's there, let's type in ll home. Here's my directory that I just created. However, the user and group are both root. We need to change that. So we'll type in sudo chown, the username that I want to change it to, the group that I want to change it to, and then the directory. So if we look at that folder again, now we'll notice Greg and Greg are the owner and the group of gregtemp1. So now we can modify our etc password file to reflect these changes. In order to do that successfully, we need to use a different command other than going into etc password. The command is called vipw. What this does is it not only locks the file, the etc password file, from other users changing that file, but it also syncs the passwords. So I'm going to scroll down and I'm going to change user Greg. Into Greg_temp1. Right quit. Okay, now you'll also get a warning. You may need to modify etc shadow for consistency. Now this is only if I am changing certain other characteristics with the user. And I can use vipw-s to do that. That will allow us to change and lock the etc shadow file. Let's also look at the groups really quick. Securing users not only ensures that we are securing a user and making sure that they own the files that they need and locking out others that might have access to those files, but also modifying groups so that we can let other users make changes to other users' directories, or if they are sharing files, to lock certain people out of other areas in other people's files. In order to do this, I would have to modify the etc group file to allow other users to be in that group. In addition to adding users and making sure that their home directories are correct and their shell scripts are correct in the etc password file, we also need to think about removing users. This is a common occurrence with organizations. If somebody leaves, we not only have to remove the file, but we also need to search for anything that the user may have left behind. When we delete a user, we're going to type in the command userdel. I'm just going to remove Greg test3. Remember, you have to use sudo here. Userdel Greg test3. Let's look at the password file. Okay, Greg test2 is there, but Greg test3 is gone. Now, when we have a user that has left the company, we also need to make sure of a couple other things. We need to remove their access from any local databases, remove any alias files that they have, remove any cron jobs. We need to remove the user's home directory or their mail queue and any other files that they may have had on the system. So let's check to see if we have any other files out there. Let's type in ll home. You'll notice that not only is Greg test3 still here, but now it has no user or group associated with it. However, it still has the security ID. So we need to remove that directory. In order to remove somebody's files, I'm going to type in sudo rm-rf greg test3. Now, make sure that you are in your correct directory before typing rf, because that stands for recursive and force. this is permanent, and if you're in the wrong directory, it's going to delete everything in that directory. So is it still there? No, it's removed. Let's also make sure that we don't have any lingering files for the user. In order to do this, we're going to type in sudo find, type in / and xdev no user. What this does is it looks for any files out there without any user associated with it. Now this may take a while to search through your system if there's a lot of files on the system. It looks like the system has found another place where we have forgotten to remove some the user's files. So let's remove that directory as well. Sudo rm var spool mail greg test3. Let's just make sure we force. Okay, let's run this command again. May take a minute, and looks like we have no files that come back. So in conclusion, we need to be very careful about how we manage users within a Linux system. It's not like a Windows system where we can just delete a user's files or just delete files and they're gone. Files in Linux stay around even though there may not be any user associated with them. In this lesson, I'll talk about Linux and access control. Access control within Linux is typically not used. However, in order to implement least privilege, we need to understand how access control works. What you're typically used to in Linux is permissions. I'll discuss permissions and discuss discretionary access control, and additionally contrast that with mandatory access control, which is SELinux. Our traditional permissions in Linux look a little bit like this. If I'm in my home directory right now, I type in ls-l for list long and my home directory. Here I can see the permissions set on the files and folders of the directory. The D indicates a directory, and the read write execute is for the owner. The next three, read write and execute here, are for the group, and the last three are for the world. So let's say that we wanted to make a file. We're going to type in vi, and let's create this in the Greg temp folder, so Greg temp, and call this testfile.log. I'm going to say this is a test. Okay, so I'm going to change directory into greg_temp. If I type in ls-l, you'll notice that it's not a directory. The very first dash here, I have read write for the owner, who is root. I have read for the group, which is also root. And for everyone else, I just have read. Let's say that I wanted to change these file permissions. The way file permissions work inside of Linux is in powers of 2. So the read is worth 4, the write is worth 2, and the execute is worth 1, totaling 7 bits. So if I wanted to change all 7 bits for read, write, execute for the entire file, I would type in chmod 777 testfile.log. ls.log. If I type in ls-l, we'll notice read, write, execute, read, write, execute, read, write, execute. This is not a very good practice, though, in theory, because now we've given anybody in the world the power to execute anything that file does. What's worse is if we allow the world to write to it, we could actually change this to a shell script and execute it because of both the write and the execute. So let's change this back to chmod 744 test file.log. Now we see that read, write, execute for the group, read, write, execute for the owner, read for the group, and read for the world. Let's say that I want to enforce or start to enforce least privilege for users inside of Linux. This is not typically done, but can be. In order to do this, I'm going to type mount-o, remount, comma, ACL, and my mount point, which is going to be the entire file system, so I type in /. Okay, let's just make sure my files are still there. Yep, they're still there. So I've remounted the / mount point just fine. With ACLs, we can add permissions to other groups or users that typically do not have access to certain files. So for example, if Apache is running content owned by a user, this typically should not be done since it's dangerous to allow Apache to run the user or root content. However, we could allow a group with other permissions to access this file. This might be a security risk, but it's better than some of the other permissions that we have out there. We could allow group and other permissions. However, this might be a security risk as well because every user could look at everyone else's home directory. In order to look at the permissions or the access control on a file, get facl and then my mount point of Greg temp. Okay, so the file is my dot, which means everything in the directory. My owner's root and my group is root. The user has read, write, execute permissions. The group has read and execute. And for other, or the world, I'm going to have read and execute. In order to do this, I'm going to type in set facl-m for modify. User is going to be Greg, and I want to do read, write, and execute for the home directory. So now if we look at the permissions again, what's going to happen, get facl/home. Now I've added user Greg read, write, execute. If I drill into what I had typed in before, you'll notice that I still have the permissions only for the root on that directory. Let's look at ls-l to see if anything else shows up. Doesn't show up here, but if I go back one directory and type in ls-l again, You'll notice here I have a plus. The plus means that I have extra permissions on that folder. The benefit of discretionary access control is it is what people are most familiar with, and it works most of the time. It's a model that distrusts users and isolates the damage that can be done by other users accessing the directories or the files. However, discretionary access control is limited in a number of different ways. We now are trusting software. We're trusting all programs the user has access to. Programs aren't limited on what they are intended to do, and the programs could have vulnerabilities that may lead to a compromise. If a user has sudo or root privileges, the system can still be compromised by other programs because we're allowing the system to execute things as that user. With mandatory access control, we are limiting the damage. This is SE Linux. SE Linux allows us to control and have least privileges much more so than we can just with discretionary access control. So in conclusion, permissions within Linux are very similar to other operating systems. However, if we want to get even more granular, we're going to have to implement discretionary access control, not permissions. This is highly recommended on any server that we have multiple people accessing multiple files, especially web servers. Today's lesson will cover working with other systems. Linux works with a variety of systems. No matter what you have in your environment, Linux is probably going to be there. So we'll discuss what Linux may connect to, discuss the purpose for Linux in an enterprise environment, and how we connect to other systems. So it's not all about Linux. Linux system administrators like to think that it's all about Linux and we can do everything on Linux. Well, I've said it before, and I'm really of the firm belief you use the technology that is best in whatever type of application you're using it in. So for user services, for example, and directory services, Active Directory for Windows is going to work best. So use whatever technology that you have available, which is ever supported, which is ever the maybe you don't have enough money for Windows Active Directory and want to roll your own Linux flavor of directory services. That's fine, but just be aware it's probably not going to be supported the way you want it to be supported. So while you can have Linux in your environment only, that's typically not the way it works in the enterprise. So Linux does not do everything well. What I tell people if they want to start getting into Linux and say, hey, you know, I really need to provide this computer to my friend and they've lost their Windows key and don't want to go get a copy of Windows. Or, you know, what about my aunt or uncle? Okay, or my parents, for example. Do you want them calling you all the time, telling you how to figure out where things are? There's just some things that Linux is not great at. It's a different way of thinking. While you probably can work your way around a Linux desktop, other people cannot and will get frustrated. If something happens, Linux is very unforgiving. So if we accidentally press the delete on something, can we get it back? Well, some distributions you can, and some distributions you can't. So you need to be careful about how you use Linux in an overall enterprise environment. Windows applications also are at the forefront of businesses. And what about Mac applications from the App Store? Those don't necessarily work on Linux. So if there's a specific software that you need running an emulator like Wine, for example, on Linux, is probably not always the best solution. It's probably best to have an actual a Windows computer to do those kind of applications. Authentication. So Linux can authenticate into a lot of different things, depending on what we integrate it into. So we can join it actually to an Active Directory domain. It serves the following purposes. It serves for security, it serves for file sharing, and it also serves trust. Okay, so security, meaning that if we have one logon to our Windows domain, we can use that same for Linux and make sure that we have a one homogeneous environment for authentication that runs off of our Windows platform. However, we've integrated Linux into the Windows environment. Okay, file sharing via something like Samba, for example, also will work as well. Also, trust relationships between different servers if we integrate that Linux system into an Active Directory domain. Linux can be authenticated into the Active Directory domain or with authentication in 3 different ways. So first of all, LDAP, second is Active Directory to LDAP, and then the third one is Active Directory to LDAP and Kerberos. So Kerberos for Windows is the de facto standard for authentication within a Windows domain. And we've seen where Linux, and I'll talk about this in a later video, we're able to have pluggable authentication modules or PAM modules that utilize different services to integrate into different environments. So there's a Kerberos PAM module that we can use to authenticate into the Active Directory domain. We also need to install some other services if we're going to do that. So Samba, for example, and Windbind are also necessities if we're going to integrate our Linux system into an Active Directory domain. There are plenty of tutorials out there on the internet how to do that. And one of them I actually have linked here in your reading for this week. Okay, why do we want to do this? Why do we want to integrate Linux with other systems? Well, in an Active Directory environment, again, we need to make sure security is first and foremost. So if we're integrating users from an Active Directory domain into a Linux domain, we can guarantee that if we shut or disable a user account inside of Active Directory, that person is not going to have access to our Linux system. Okay, auditing is also necessary. So if we tie the two together or tie multiple systems into Linux or Linux into multiple systems, we can audit the entire environment and have a holistic picture of what is going on with our environment. Local accounts should not be used within Linux if it's an enterprise environment. That's for security reasons. Whenever we're installing other open source software, typically we're going to integrate LDAP or lightweight directory authentication protocol, to look at authentication between some kind of authentication system and our software. Linux installations may use third-party software for that authentication mechanism. So, for example, Splunk. If you're looking at this specialization from Coursera, we cover Splunk in another module. So I use LDAP for Splunk to authenticate my users in the Active Directory domain. However, my Splunk is running on a Linux server. So software also may require some type of authentication to integrate. So in conclusion, while Linux can stand on its own, it may not be the best use case for a lot of different things. Perhaps Linux is going to be best used for web servers or specialized distributions like for security, okay, or file services or DNS. It's probably not going to be used very much in as a desktop environment, for example. So security is also a major consideration when we need to work with other systems. So we need a holistic picture of our entire environment and integrate all those services such as Samba and Winbind and Kerberos into our Linux environment to make sure that security is always being considered.